So V of t will be given by r dash of t, so that will be 4ti plus 2t minus 4j plus 3k varum, and the acceleration will be the second derivative of r of t, so that will be 4i plus 2j plus 0k. So therefore we need to find the velocity and acceleration at t equal to 1. So v of 1 will be 4i minus 2j plus 3k varum, and a of 1 is 4i plus 2j. So we have got v of 1 and a of 1. Now we need to find the component in the direction I minus 3j plus 2k. Okay. So the component of v of 1 in the direction of I minus 3j plus 2k. So that will be equal to v of 1 dot the unit corresponding unit. So I minus 3j plus 2k by root of 1 plus 9 plus 4 varum. So v is 4, 2, 3. Minus 2. Dot I minus 3j plus 2k by root 14. So that will be 4 plus 6 plus 6 by root 14. So we get 16 by root 14. And again component of a of 1 will be equal to a of 1 will be 4i plus 2j. So 4i plus 2j dot I minus 3j plus 2k by root 14 varum. So that will be 4 minus 6. So minus 2 by root 14 will be the value. Next problem is to find the tangential and normal component of a point, normal acceleration of a point moving in a plane curve. Now let a of t denote the acceleration vector. Now acceleration at any point will be a resultant of a tangential component and a normal component. So we can express acceleration as at into t plus an into n. So this is the component of acceleration in the tangential direction, and this is the component of acceleration in the normal direction. Okay. If this is our curve, r denotes the position vector, and this is the curve on which the particle is moving. So at any point, acceleration has components in the tangential direction and normal direction. Okay. So this basically explains the fact that what is the change in motion when speed increases. ഇപ്പം സ്പീഡ് കൂടുന്നതിനനുസരിച്ച് മോഷന് വ്യത്യാസം വരുന്നുണ്ട്. അതുപോലെ നമ്മളൊരു നമ്മുടെ പോകുന്ന പാത്തിന്റെ വളവ് കൂടുകയാണെങ്കിൽ you know that we will be moving towards that side. Okay. നമ്മുടെ ബോഡി ആ ഒരു സൈഡിലേക്ക്, അതായത് നോർമൽ ഡയറക്ഷനിലേക്ക് ആയിരിക്കും മൂവ് ചെയ്യുക. അതായത് കർവേച്ചർ കൂടുന്നതിനനുസരിച്ച് you will move in the normal direction. When speed is increasing, you are moving along in the tangential direction. So acceleration at any point will be a resultant of the tangential component and normal component. Now we are asked to find what is the value of the tangential and normal component. So So we need to find this AT and A. So for that, we need to express A in the form ATT plus AN N. So we'll start with R of T and let us find an expression for acceleration in this form. Okay. From here, I have taken the curve. So R is a position vector at point P. So T is a tangent vector and the vector perpendicular to that will be the normal vector. And let me take this angle to be xi. Now R is the position vector of a point P at time t. Then the velocity vector v is given by dr by dt. Now by using chain rule, so the position vector, so r can be a function of arc length and arc length can be a function of time. Okay, so the position changes with respect to arc length and also the arc length changes with respect to time. So therefore by chain rule, so dr by dt will be equal to dr by ds into ds by dt, where s is the arc length, so s is denoting the arc length. Now നമ്മൾ T of T യുടെ definition കണ്ടപ്പോൾ കണ്ടു dr by ds എന്ന് പറയുന്നത്, so T is also equal to the tangent, unit tangent vector in terms of arc length, so that will be equal to r dash of s. So here this will be equal to ds by dt into t1. So this is the unit tangent vector. So this is the unit tangent vector. So therefore we will get b equal to ds by dt into t. ഇനി നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് acceleration ആണ്. So acceleration will be the derivative of the velocity function. So therefore now a of t will be equal to dv by dt. So that will be d by dt of ds by dt into t. Okay. So now this will be equal to d square s by dt square t plus ds by dt into dt by dt. Now if you take dt by dt, okay, so this is the derivative of the tangent vector. Now as you know, here the tangent, as the tangent changes, so your angle also keeps changing. Okay, അപ്പം xi മാറുന്നതിനനുസരിച്ച് നമ്മുടെ ആംഗിൾ ഓഫ് ഇൻക്ലിനേഷൻ മാറുന്നതിനനുസരിച്ച് ടിയുടെ ഡയറക്ഷനും മാറും. So again you can express t to be a function of xi, and this xi again depends on t. t മാറുന്നതിനനുസരിച്ച് xi-യും മാറിക്കൊണ്ടിരിക്കും. So therefore I can write dt by dt as dt by d xi into d xi by dt. Now we get d square s by dt square t. Now we can replace dt by dt, so that will be ds by dt into dt by d xi into d xi by dt. And now as you have seen, നമ്മൾ t of t, the tangent vector t is equal to r dash of s with respect to the arc length, and same way if you take t dash of xi, so if xi is the angle the tangent line makes with the x-axis, then the vector n will be given by t dash of xi. അപ്പോൾ നമ്മൾ t dash of xi എടുക്കുമ്പോൾ t dash of xi will give the normal vector. So here dt by dxi will be actually the normal vector. So d square s by dt square t plus you will get ds by dt into dxi by dt into n vector. So we will get here d square s by dt square t plus ds by dt into dxi by dt. This will be equal to d square s by dt square t plus ds by dt into, now xi is a function of t. Now xi changes with respect to t here. Now we can take by chain rule xi to be a function of s, then s to be a function of t. Okay. കാരണം xi value changes with arc length changes. അപ്പോൾ arc length മാറുന്നതിനനുസരിച്ച് നമ്മുടെ കർവിലെ പോയിന്റ് മാറും, അതിനനുസരിച്ച് കറസ്പോണ്ടിങ് xi value മാറും. So by chain rule, so dxi by dt will be equal to dxi by ds into ds by dt. So we will get ds by dxi by ds into ds by dt n. So here we will get ds by dt whole square. Okay. So therefore a of t will be now equal to d square s by dt square t plus the second term will have dxi by ds into ds by dt whole square n. Now this quantity dxi by ds, so that is the rate of change in the angle of inclination with respect to the arc length. So this is actually called the curvature of the given curve. So therefore we will get, so we usually denote dxi by ds as 1 by rho. So this is the curvature of the given curve. So therefore we will get a of t as d square s by dt square t plus rho is for dxi by ds, and let me put small v to be ds by dt. So we will get v square n cap. So this is the tangential and normal components of acceleration. So therefore the tangential component is, so that is equal to d square s by dt square, and the normal component is, or we can also write it as നമ്മൾ ds by dt നെ v എന്നാണ് കൊടുത്തത്. So that will be dv by dt, and the normal component is equal to d square by rho. So that is how we find the normal and tangential component of acceleration.